Happy morning to one and all. Next, I would like to share the another new topic about the thick cylinders. In the previous video, we can discuss with the thin cylinders. Now, I would like to share the few things about the thick cylinders. Yeah, thick cylinder is the pressure vessels whose wall thickness is larger compared to its internal diameter. Unlike thin cylinders, the stress distributions across the thickness is not uniform. Thick cylinders are used when the internal pressure is very high. For examples, hydraulic pressures and gun barrels and high pressure pipes, nuclear reactors like power plants. This kind of area we can majorly use for the thick cylinders. Then how we can identify the conditions to make the confirm either thin or thick cylinders? It's nothing but the d by t, diameter by thickness less than of 20. That's why we can say as the thick cylinders. Then what are the characters of the thick cylinders we can having means wall thickness is completely large, radial stress is the significant, hope stress varies across the thickness, inner surface experience the maximum stress, designed for high pressure applications. So next we can discuss through stresses in the thick cylinders. So what are the stress to be added for the thick cylinders, like circumferential stress or an hope stress, radial stress, and as well as the longitudinal stress. First we can say as radial stresses. Radial stress acts the perpendicular to the wall thickness. That's why we can calculate as a radial thickness. So maximum at the inner surface and minimum at the outer of the surface. That's why we can calculate for the radial stress. And the next one is like a hoop stress or a tangential stress. This is the most important stress in the thick cylinders. Maximum at inner surface and decreases towards the outer of the surfaces. Then how the radial stress along with the hoop stress we can calculate it in the sense like for the formula like B by R squared minus A, it can be calculated by the radial stress, as well as the hoop stress. Instead of the minus we can add the addition, like it's nothing but B divided by R squared plus area. So like A, B are the variable constraints we are using the terminologies. Then what are the boundary conditions we are follow to the thick cylinders, like internal radius, internal pressure, external pressure, and the radial stresses. Then how can we calculate in the maximum hoop stress? So the maximum hoop stress we can calculate it with the help of the formula like stress maximum is equal to P within a bracket R2 squared plus R1 squared divided by R naught squared minus Ri squared. So R naught Ri in the sense of outer radius and as well as the inner radius. Then how we can calculate it with the longitudinal stress for the particular thick cylinders? It can be calculated by P into R squared divided by R naught squared minus Ri squared. Then how we can calculate in the compound thickness of the thin cylinders? Sometimes two cylinders are shrinkage together to form the strong cylinders. So it is the major purpose to implement for the industry to reducing the maximum thickness of the maximum tensile stress along with the increases pressure carrying the capacities, and as well as the improving the fatigue resistance. And thick cylinder major applications like gun barrels, hydraulic cylinders, as well as the heavy pressure vessels. Then autofretigage process, we can carry out the strengthening the process where cylinders are subjected to very high as well as the internal pressure is high, and the inner layer of the cylinder yield stress towards the plastically, and residual compressive stresses to be developed. What are the benefits we are making for together making the cylinders means increase the fatigue strength as well as the life, and a higher pressure capacity, and used in the gun barrels, high pressure pumps. And what are the challenges or what are the applications to be carried out for the making the thin cylinder means gun barrels, like it can be it can be exposing the extremely high pressure, internal pressure during the firing. What are the requirements that are needed? High strength and resistance to bursting, heat resistance. Then next one area, hydraulic pressure cylinders. Hydraulic system operates under the very high pressure range. It can be used in the pressure machines and lifting of equipment from one place to another places, and industrial formation of the machining. Last one is high pressure boilers. So power plants using the wall thickness vessels for making the steam generation as well as the heat dissipation from one place to another place. So these are all the interesting topics which we can be discussed for the thick cylinders. Thank you all.